Thank you. Aditi, kindly write to us at IS Live and it will be taken care of. Meander is basically, Gaurav, when the river has got a very slow speed. At that point of time or in that phase that is observed in the mature or late mature stage, the river is unable to chart a straight path. It is in that course that river ends up charting a kind of a wavy pattern of movement, and that is what we refer to as the portion, or what we refer to as a meander. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geography, where now we shall be proceeding ahead with the portion of karst topography that we had initiated the discussion for yesterday. And that is how we shall be finalizing the portion of geomorphology as such. So, yesterday we were discussing and we had initiated a discussion about the exogenic forces which act on the planet surface. Now, these exogenic forces, they are referred to as exogenic. Why? Because they act from the outside, be it the event of weathering, mass movement, or even the landforms that we have seen till now getting created. They are not getting created due to internal actions of the planet Earth. They are getting created purely because of the outside intervention and the outside impact on the surface that is created. So, here, while taking a look at the portion of the underground landforms created by water, we had taken a look and we had understood that basically the water in itself, the rainwater or any kind of water, will have its solution properties where it will be able to dissolve materials which are soluble in it. So, in that circumstance, if you have a kind of a rocky substance or a land which is rich in those particular materials or minerals which are easily soluble in water, now in that case, what will happen? You will have creation of very large cavities. And as the water keeps on dissolving materials on the rock surface, it ends up charting its own path. And due to that process, it ends up creating erosional as well as depositional features. Now, erosional features we had looked at yesterday, where we observed the formation of sinkholes, uvalas, as well as the caves. Now, when we talk about the sinkholes, a quick recap of how these sinkholes they are getting created is basically when you observe any particular region, let's suppose which is rich in a particular kind of a mineral, let's suppose calcium carbonate. Okay, now, here, if let's suppose this entire ground region is very much rich or is made up of limestone rich in calcium or magnesium carbonate, in that case, if there is copious amount of rainfall which occurs, significant amount of rainfall which occurs, it will start dissolving the materials slowly and steadily. And the entire region might even cave in, and that leads to creation of large sinkholes in the process. Now, many of the times these sinkholes they will combine together to form what are referred to as a valley sink. They end up forming a continuity of these sinkholes which we refer to as valley sink. Sometimes it also happens that you can have the water dissolving the materials, and the water not only dissolving the materials but paving its own way in the process, and thereby forming very large cavities that are referred to as caves. But then, when we talk about the depositional feature, What are these depositional features and how are these depositional features created? So, in order to understand that, one basic analogy that I want you to frame is basically the one that you would have witnessed from your childhood days itself. I'm sure many of you would have seen the older buildings and the older houses as well. In many of the cases, you would have had your first hand experience of living in a certain region or a certain house where, let's say, a government quarter, for example, is the best example of this, where you will observe that seepage occurs during the month of the rainy season. Now, when the seepage occurs, if ever you have observed that seepage from happening from the ceiling of your room or any particular room, you would have observed that it is not as if water starts draining in large bulk. It forms small trickles and then drop by drop it keeps on falling. A very similar event happens in the case of these large limestone caves as well. How? So, for example, let's suppose you have a particular region, a rock layer, which is rich in limestone. Let's suppose underneath that you have the cave like structure. You have a cave like structure. And here, let's suppose you have limestone bed. This is the surface, ground surface. Now, here, many of the times, what happens is, let's suppose there is some water which starts dripping out. Let's suppose there is some water in the form of rainfall or anything which seeps through the surface. Now, as the water droplets would be seeping through the surface, they would be absorbing the minerals all around them, isn't it? They would be absorbing and taking in the minerals all around them. They would be dissolving them. And then eventually the water droplet would form here. Slowly and steadily, that droplet would be created. The droplet, when it becomes large enough, it might end up falling on the ground. But many of the times it happens that a large droplet gets created and thereby the droplet evaporates from that portion itself rather than falling. It can happen that a droplet gets created here and it gets evaporated without any falling action which takes place. So, when a solution evaporates, the material, the content which has been dissolved, that gets left behind. I'm sure you would have experienced this, that whenever evaporation takes place, it is just the pure water which gets evaporated, not the salts which are contained in the water. That does not get evaporated, that gets left behind. So, here also, when you have that kind of a factor where the droplets get created and they get evaporated from there itself, they will leave all the materials that they had dissolved, they will leave it behind. They will leave it behind in the form of, let's suppose here, they will be leaving it behind. Okay. Furthermore, after some time, let's suppose another droplet develops here after maybe multiple, and time is something which is not fixed. It can happen within a few weeks, it can happen within a few years, it can happen within a few decades as well. So, there also the water can end up evaporating, leaving behind everything that was dissolved in it, the calcium and other materials which were dissolved in it. Now, calcium has got a kind of a binding property. So, when the calcium gets left behind, it will basically leave the deposits which will bind themselves. So, as this process continues, eventually you come across a kind of an icicle like, ice like structure which appears to be suspended from the surface, from the roof of the cave. Okay, and this is what is referred to as stalactite. That is what you refer to as stalactites. Now, sometimes it can also happen. Let's suppose you have a water droplet which falls on the ground surface. After falling on the ground surface, that water droplet then evaporates. Now, if the water droplet evaporates after that, then on the ground surface, it will leave those deposits. Then let's suppose there are further droppings of the water, and the water which has contained a kind of a solution, further droppings can happen, and this will continue to pile up, right? It will continue to pile up. And automatically, as it continues to pile up, because that is where the droplets are falling, and the droplets getting evaporated will leave behind those calcium deposits. It appears like a standing structure on the ground surface, which is not very thick or which is not very large, but it will again have that kind of an icicle like formation, something that you will also experience in your refrigerators sometimes, in the freezers of your older refrigerators that you had. So basically, in those freezers, you would observe these icicles which would be suspended from the surface, or which would basically accumulate on the bottom surface. So once it happens on the bottom, that is where we refer to it as stalagmites. Okay. So that is how you have the stalactite and the stalagmite formation. Stalactite formation, when the droplets they start appearing on the roof and they evaporate from the roof itself. So they will leave behind everything that they had dissolved. Further droplets which will get created, if they also evaporate, they will leave behind further deposits. So like those, like that, because the deposits they consist of calcium, and the calcium has got a very intense binding property. That is why you get that suspended ice like structure. When it is attached to the ceiling, it is referred to as stalactite. When it has got its base on the ground, which is fixed, then we refer to it as stalagmites. Now, sometimes what also happens is that these stalactites and stalagmites, over a period of time, it can also happen that they join together in certain areas. That can also happen. So when they join together, when they form a like a common and a continuous structure, that is what is referred to as a kind of a pillar or column. Okay, that is what is referred to as a column or pillar. Okay, so in majority of the limestone caves, you will come across these particular scenarios or these particular stalactites and stalagmites, and they have been created over a period of many hundreds and thousands of years. So it starts increasing, the size of it will increase very very slowly. So the process is slow, the process of creation is slow, but then they are pretty strong structures overall. So where will you find it in India? So in India, you will find them to be present in the region of, let's suppose, Yana caves in Karnataka. For example, in the region of cave-like structures in the region of Meghalaya, that is around Cherrapunji and Mawsynram. So in all these places where you have very distinctly present large limestone caves, you will come across these particular scenarios. Okay. Now, after this, we move ahead with the landforms developed by the glaciers. Now, when we talk about glaciers, as we have already talked about earlier in the case of the continental drift theory as well, that the glaciers, they are one of the most formidable forces of the nature. They are one of the most powerful forces that the nature has got to offer. Because when we talk about the glacial movement, you have very, very large chunks of ice which move down the slope under the influence of gravity, but the movement is also distinctly slow. The movement of glaciers is not something that you can catch with your naked eye. It is only with a kind of a long range observation and a long period observation that you get an idea, okay, that maybe the glacier is moving, but not with a naked eye. So, for example, just to give you an idea, so here, let's suppose if you take this particular image, and here I want you to concentrate on the images of now. So, here, what you observe here, the ice which starts falling, the ice which starts rolling down, that is a glacier. Now, this glacier is what you find at the base, near the base camp of Mount Everest. This is what is also very famously or infamously referred to as the Khumbu Ice Fall. And this is also one of the regions where the people who go to trek and summit the peak of Mount Everest, this region claims many lives every year, because this is ideally a glacier and people are supposed to trek upon this. But then if you analyze it from a far away distance, it might appear like an ice which is simply moving. But upon closer look, this is what that glacier looks like, the second image. And this is, just for your point of reference, the size of an average individual. So that gives you an idea about how very large chunks of ice, they are very slowly moving down. Each of these chunks, they can be as high as 4-storied, 5-storied buildings, and they are moving ever so slowly. So here, when they are moving, they will be exerting a lot of force on the bottom surface of the rock. Lot of force. So whenever a glacier ends up moving, it will exert a significantly high amount of force. And due to that force will have a crushing action or a crushing impact on the ground surface or on the rocky surface. Now, due to that crushing impact, many of the larger rocks, etc., they will get pulverized. They will get smashed and reduced to smaller particles. And that is what the glacial deposits consist of. Because even in this image, if you will observe that there are certain glacial deposits happening here, and even this portion represents certain deposits, even this portion represents certain deposits, even this portion represents certain deposits. So, once the glacier moves over a particular rock, it will basically put so much of pressure that significant amount of that rock will be eroded. And once that rock is eroded, it will further be crushed by the weight of the glacier. And you have very, very fine particles which are rich in minerals which are carried out. So, those fine particles which are deposited by the glacier, what are they referred to as? We have studied it earlier. What are the fine particles deposited by glaciers referred to as? Beautiful. Very good. They are referred to as glacial till or tillite. So, glacial till or tillite, that basically refers to very fine particles deposited by the glaciers. Okay? Glacier moving means it's falling down. Are it moving individually? How will it move individually, my dear friend? The entire ice structure will be moving. So imagine if this is the glacier, or think about this particular image. So all that ice which is present, slowly and steadily, it will form a kind of a movement, and it will be moving as per the slope, right? So that is how it is moving. And wherever the speed will be significantly slower in comparison, that is where the deposits will happen. So when the glacier deposits, observe that it is depositing here as well. It is depositing here as well. It is depositing on the sides as well. So as the glacier moves, the deposits that it carries out on the sides and in between, these are what are also referred to as Moraines. Moraines. These are depositional structures or depositional features formed by glaciers as they move down the slope. Now, depending upon how and where these deposits have happened, the moraines also have got their own distinct name. For example, as a glacier moves and it deposits substances on the sides, that is what is also referred to as a lateral moraine. So, what you observe to be deposited here, that is also what is referred to as a lateral moraine, for example. Right? For example, if you observe certain deposits happening in between, so these will be referred to as medial moraines. Then, for example, if I take you back to the previous image of the Khumbu icefall, if ever you have some time and with your hand in your hand, where you are having that kind of a flexibility where you can read certain books and reading of books is something which is always encouraged in order to clear the civil services. It is always encouraged to read as many different books as you can, so that not only to accrue knowledge but also to improve your English vocabulary, and also to in order to have a better command of writing skills as well. So while I suggest books whenever I get the opportunity to take an essay interaction and essay class with the students, I always end up suggesting them many of the books. But because we are in the portion of glaciers and ice, and we are talking about Mount Everest, so if ever you get an opportunity, do explore a very thin book that is there, that is Into Thin Air. That talks about a kind of a woeful Everest expedition which happened some long time back, which claimed many lives, which was later on adopted to make a kind of a Hollywood movie was also made upon that. So you will get an idea about how treacherous these glaciers are, because all these glaciers, ideally you have to skip through them or you have to walk on top of them. There is always a danger that you can fall in between. And that is also one of the reasons how, when you correlate it to the portion of border security, I'm sure you would have studied about the Operation Meghdoot of Indian Army. And by the way, that Operation Meghdoot of Indian Army is associated with what? Let me see. See, very good, Anurag. Very, very good. Anyone else? If they are aware of Operation Meghdoot, which was carried out in 1984. Kamalpal, very good. Bhagya, correct. Sumo, correct. Garvit, correct. It is basically the capture of Siachen. Now, Siachen is one of the highest, or it is the highest battlefield across the globe, and it is one of the largest glaciers which are present outside the polar regions. Now, Siachen, over the period of many decades, and I'm sure you would be aware about it as well, has claimed many, many lives. Many, many lives. And in many of those lives which have been claimed, the unfortunate events where the glacier claims the lives is where you end up falling in between these cracks and crevices and in these gaps that the glaciers hold. And that is where you can fall down many, many feet, and there is no way in which you can be rescued in time. and the temperature is so very low that if you are not rescued within a few hours, then the chances of survival is almost negligible. So that is where the glaciers, they are very treacherous. But once the glacial melt happens, let's suppose in a region 400, 500, or let's suppose in a region 50 million years ago, there would be an existence of glacier. And over a period of time, that glacier has melted. What it would leave behind is going to be a trail of those deposits and those landforms, which will hold an evidence that yes, a glacier has existed in that region. The name of the book basically that I suggested was the Into Thin Air. It has been so it has been written by John Krakauer. So you can basically take a look into that. It is only for your, please don't think about it that this will help you in your civil services examination, because the question is going to be asked from that. So if you have leisure time, only then you read the books. If you are in a habit of book reading, only then go for it. Otherwise, I get many complaints from the candidates as well that you suggested so many books. Who will study Lakshmikant and Bipin Chandra if I start studying those books? So please decide your priorities and don't pin it on me that this person had told me to study that book. So that is a good book which tells you about the treacheries of the glaciers in general. Yes, Vivek, that is correct. In the sense, when we talk about these glacial deposits, they are very fine particles. They are referred to as till or tillite. Now, those tillite, when they are getting deposited at the side and during the movement of the glacier, that is what is referred to as moraines. Now, when they are deposited on the sides, they are referred to as lateral moraines. When they are deposited in between, for example, this, if you observe this, Khumbu Ice Fall. So this is what is going to form your medial moraine, because it is formed in between. Now here you find that the glacial movement ends in a way, and then you have those deposits. Maybe after this, the glacial water gets converted or melts into liquid stream, or the glacial ice gets converted into liquid water and that starts flowing. So, all the deposits that it had, it will deposit beyond that, and that is what is also referred to as end moraine. Okay. 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 I guess people are getting confused between moraine and till. Hmm. So, think about it in that respect. When we talk about the river, when the river moves, it carries small sediments which are referred to as silt. Now, that silt gets deposited, forms floodplains. That silt gets deposited, forms natural levees. That silt gets deposited, forms braided channels. So, that is the difference. If you are able to understand the difference between the silt that the river carries and a floodplain, I hope nobody is getting confused between the river silt and a river floodplain. So similar is the case with the glacial till and the moraines as well. So moraines are constituted of the various different glacial till or tillite deposit. Is that understood? All of you who were asking. Urmila, Mayank, all of you. Good. Now, that is basically the deposition which is carried. So when you talk about the moraines, so I'll show you the slide for the moraines here. Observe, now this is a schematic. It represents that wherever the deposits of the tillite happen or till happen, that will form a kind of a moraine like structure. So when it happens on the sides, when the deposits, they keep on happening along the sides, that is what is referred to as lateral moraine. When the deposits, they happen in between the movement of the glacier, medial moraines. When they happen after the end of the glacier, where the glacial ice gets converted into thin streams of water, that is what is referred to as end moraine. Now, end moraine is also basically of various different types, not very much important, not very much required, but basically there also you have the last series of deposits. They are referred to as terminal moraine, right? Then slowly and steadily due to climate change or due to global warming, the glacier starts melting at a particular height itself. Earlier, let's suppose the glacier would melt here. Now, the glacier, because of increasing temperature, the glacier will melt here itself. Again, the temperature will increase, so now the glacier will start melting here itself. So, that is what is referred to as the receding glacier or the recession of a glacier. So, when you talk about recession of a glacier, Mirzana. So I hope you liked the book, Mirzana. So when we talk about recession of a glacier or receding glacier, so that is what, in simple terms, it is basically when the glacier starts to melt at a greater height as compared from before. And why does that happen? Due to rising temperature. Okay. So slowly and steadily, as you will observe that the glacial retreats or the glacier actually recedes. In that case, you will observe that the moraines also keep on getting deposited. So that is what is also referred to as recessional moraine. So wherever the glacier starts to deposit substances. Now let us take a look at few of the erosional landforms. Now, one of the most massive erosional landforms created by a glacier, which no other agent of nature can create, is a cirque. Now, when you observe a cirque, so observe this particular image here. Observe this particular mountain set. Now, it will give you an appearance that the entire region or the entire mountainous area as if it has been scooped up. Somebody has scooped it up, like you do in the case of an ice cream. So, somebody has scooped it up. So that is basically created only because of glacial movement. So imagine at one point of time, if you can, that this particular entire region would be covered under glaciers, and the glaciers would have had their movement somewhat like this. Now, over a large period of time, as the glaciers have melted, they have left behind the landform, the eroded landform. And here, what meltwater that you see, this is what is also referred to as a glacial lake. Many of the times you come across that phenomena as well in different parameters. So this is your glacial lake. Now, in this entire region, an amphitheater like excavation has been carried out. There has been a scooping up whereby it is as if the entire mountain has been carved out and a large amphitheater like carving out has been done. And that erosional landform, which appears like an amphitheater because of the carving of the glacier, that is what is referred to as a cirque. So, cirque is a very large amphitheater like formation that you will observe. Okay. Now, after this, we also have the condition of arêtes and horns. So, in order to understand arêtes and horns, think about this particular cirque. Now, in this cirque, you will observe that from one side, there has been a glacial erosion and glacial action which has happened. Now, imagine a circumstance where from the other side also, from the other side of the mountain also, if the glacier would have carried out the same action, then what would have happened? If the glacial action would have been carried out from both sides, then erosion would have happened from both sides, leaving behind a very narrow, thin ridge-like portion, isn't it? Leaving behind a very narrow, thin ridge-like portion. And that is what we refer to as an arête. So an arete is a narrow, thin, ridge-like portion where a particular mountain has been eroded on both sides by the event of the glacial action. Okay, so this is a narrow and thin, ridge-like landform is created due to the glacial action on both ends of the mountain range. Okay, by the way, guys, before I forget, the map pointing portion that I have been giving to you, is it something that you guys have done? Or is it something that you guys have actually managed to take a look into? Please let me know. Because immediately on the next day, I don't ask you guys because I don't want to be a class sixth level condition in this class that next day show me your homework. But I expect you to, because now almost a week and a half has passed. So I expect you to be going through the various different mountainous areas and the fold mountains, the deserts, etc., which I have indicated to you as a kind of a map pointing. So all of you who have already done that, fair enough. But any of you who have not done that, kindly take a look into this. This is for your own level of improvement and your understanding. And today, also at the end of the session, I will give you certain more portions for map pointing, and that will be for your benefit itself, where we shall be talking about certain other areas, certain other world regions, landforms, etc. So you have to take a look into that as well. Okay, so do we need to locate them and surrounding also on a blank map? Not needed, my dear friend. I just want you to be aware of where the regions are. So even if you are able to pinpoint them on the atlas and then explore the surrounding regions, that will also be sufficient. Okay, now here coming back to the topic, arêtes basically are very thin, such ridge-like features or landforms which get created because the glacial action is happening simultaneously on both sides. Then imagine a circumstance where a particular mountain feature or a ridge like feature is experiencing this glacial action on three sides rather than two sides. Let's suppose it is experiencing it on three sides. So, when it is experiencing it on three sides, what do you have? You have a kind of a isolated peak like feature. Isolated peak like feature is created, and that is what is referred to as a horn. So that isolated peak-like feature, that is what is referred to as a horn when the glacier has eroded from all the sides, leaving behind a small peak-like feature or a small pointy feature. So this is what you refer to as a horn. So this also gives you an idea about how over a period of time the mountains get eroded. Because imagine initially the mountains will get eroded like this, right? And then you might be left with a kind of an isolated peak-like feature here, isolated peak-like feature in this condition. And then this particular portion will also be exposed to weathering. So once it is exposed to weathering over a period of hundreds of years or thousands of years, this might disintegrate, this might break. And then furthermore, that weathering action will continue. That is how the mountains, large mountains over a period of time, they get weathered into very smaller ones. The process of formation or upliftment of the mountain and the weathering and the exogenic forces, they keep on happening simultaneously. Depending upon which keeps on dominating, that is where the size and the height of the mountain is determined. For example, when we talk about the region of Himalayas, in the region of Himalayas, the size or the height is still increasing. Why? Because the folding is still very predominant. But some or the other weathering action does take place. The moment that folding process comes to a stop, that is when the elevation of height will also come to a complete standstill. After that, you will not have any further elevation in height, and then the degradation in height will happen. For example, take the case of Aravalis. Now, Aravalis are amongst one of the oldest fold mountains of the world. And at one point of time, it is estimated that the Aravalis had such a great height that glaciers used to move or originate from that area. It is estimated that the Aravalis would also have various snow covered and ice covered peaks long, long time back, hundreds of millions of years back. But once that folding process stopped, once that rise in elevation stopped, what does the weathering or what has the weathering and erosional action led to? Observe the Aravalis now, where on any fine afternoon, if you take a particular peak, you can actually trek through a particular peak and you don't have any existence of ice or glacier anymore, right? So the height keeps on reducing. So even the present day mighty mountains that you find in the region of the Himalayas, hundreds of millions of years from now, it might be completely possible that it might be reduced to a smaller mountain range, or their height might be reduced over a period of time due to weathering and erosion. It will happen, in fact. Okay. Now, then after that, we come across certain other depositional features other than moraines. And these are created when you have a large scale glacial movement happening across a kind of a plain area, happening across a region where there is a slight amount of slope, but it is a largely plain area. And this is experienced in the region around Western and Northern Europe, for example. Because whenever the planet Earth goes through an ice age, there is incredible amount of freezing, and freezing in the ice age is restricted in the temperate regions of the world. It is restricted in the higher latitudes of the world. The regions around equator, they never get frozen, but the higher latitudes of the world, they get completely frozen during an ice age. And again, the de-icing phase comes when everything melts. So whenever that ice age comes, now, during that particular ice age, you have glacial movements. For example, the region of Northern Europe and Western Europe has experienced a large scale freezing where the ground that you see now would be completely frozen and would be covered in ice, and that ice would move over large plains. Those are what are also referred to as continental glaciers. Now, these glaciers, kind of glaciers, are in the present context, they are found in the region of either Antarctica or in Greenland. It is only in those areas where still such kind of glaciers exist. Now, when these glaciers they are moving over a large plain area, many of the times, as the speed reduces, they end up depositing materials in a kind of a format which resembles an egg kept laterally. And that is what is referred to as a drumlin. So these drumlins in one particular region, if you take a look, let's say you take an overview or a top view of a particular area. Okay. So here you will observe these drumlins. They appear in very large numbers. As the glacial speed would have reduced, the glacier would have deposited all of this. And all of them, they appear as protrusions emerging from the ground surface. Drumlin looks same like arêtes. What are you talking about? Arêtes are high altitude mountain ridges that you are talking that you have. And if you find similarity in drumlins and arêtes, you have a knack, and you will be able to find similarity in many of the images around the world then, which is a good feature. But here it is not going to help you. So Overall, if you will observe, this is basically a kind of a mound like feature. This is the cross sectional view, right? That is the cross sectional view that you will observe here. So this is what is referred to as a drumlin. Now, when taken a look from above, it will give you an appearance many of the times that there are many such eggs which have been kept. So when you take the case of an egg, mostly when we take the case of an egg, we find it, or the image that we can recollect is egg which is standing, but an egg kept in lateral position, that resembles the shape of a drumlin. So that is where the region where you will have a lot of these drumlins, this is also what is referred to as basket of eggs topography. Basket of eggs topography. Okay. So because of the shape that it has. So observe here, this is a typical drumlin that you will observe. So these are hills of sediments, generally a quarter or of a mile or more in length, that have been streamlined by glacial flow. Thus, they are often elongated. They often occur together in fields, some with as many as several thousand individuals in a particular region. So that is a drumlin. So how is it that the drumlin is created? Let us understand that. So basically, it is deposit. Now here, let's assume that in a particular region, here you have the land, and let's suppose the glacier is slowly moving in this direction. Now, as and when the speed will reduce, let's suppose the speed has reduced here ever so slightly. So the materials will get deposited in this region. The finer particles that it has been carrying, the smaller rocks that the glacier has been carrying, it will get deposited. Now, once the deposit has happened, it will further slow down the speed in this vicinity, in this locality. So that will further increase the size of it. So that is how slowly and steadily more deposits will end up happening here because of the obstruction and because of the significant amount of slowing speed. So these deposits happen due to the slowing speed. These deposits end up happening due to the slowing speed. Now, as these deposits happen, the glacier will also exert its own weight, and the glacier is also going to be continuously moving in some direction. So that is where the glacier will provide a kind of a shape which is streamlined towards the direction of motion. So you will observe that the glacier is able to streamline it towards the direction of motion. And that is why it has got that kind of a shape associated, a kind of an aerodynamic shape that you will observe is associated because you have those particular movement of the glacier and streamlining of the glacier being done. So this particular mound of deposits are streamlined in the direction of glacial flow. Okay, that is how you have these deposits getting created. Now, these deposits oftentimes are to be found where? In the region of Western and Northern Europe. In India, you don't find many such instances of drumlins. You have certain instances, but not very prominent amongst them. So, mostly to be found in Western and Northern Europe, and also in the northern stretches of North America, all those areas which had been influenced during the last ice age. Now, these glaciers, they give you an idea or an impression of an egg kept laterally. And as they appear in hundreds or maybe thousands in a small area, from top view, they will always give you an idea or an impression that it has consisted of multiple different eggs, and hence referred to as the basket of eggs topography. Okay. Now, that is drumlins. Then we have another kind of deposits made by the glacier, and that is again the deposit which is made in a kind of a linear fashion, and that is what is referred to as eskers. So eskers basically are ridges made of sand and gravel deposited by the glacial meltwater, flowing through the various different crevices, cracks in the ice movement underneath the glacier, and thereby you will observe a kind of a linear deposit. Observe the linear deposit here, right? Observe this. Now, these linear deposits which have been carried out, these are what are referred to as eskers. Now, if I ask you a logical question here, that these eskers, this region, will it be fertile or will it be not fertile? What do you think? Will it be infertile or will it be fertile? Very good. This will be very, very fertile. All the glacial deposits, majority of the glacial deposits that you find, they will end up being supremely fertile. Why? Because they have been formed by glacial till, and that glacial till consists of various different minerals that has been extracted from the rocks as they have been eroded. So these are considered to be very, very fertile because of the fine particles and also the minerals which are present there. Okay. Now, then we come to the landforms which are developed as a result of the wind action. Now, wind also has got significant amount of power in order to be able to create and carve various landforms. Now, when we talk about the wind, where is it that the wind will have maximum amount of power? It will be in that particular region where the speed will be very high. Now, the speed will be higher where? If I ask you, in a forest or in a desert, where is it that the wind will have a greater speed? What do you think? Very good. Desert. So that is why wind has got maximum. And why is it in the desert that the wind will have greater power? Because in the region of the desert, you don't have those many obstructions, those many resistances in the form of trees, etc., which can reduce the wind velocity. That is why the wind speed is high. So, wherever the wind speed is very high, it is only in those conditions and those regions where you will observe the formation of these landforms. Landforms created by wind, they are also what are referred to as aeolian landforms. So these will be observed in arid and semi-arid areas, regions where the wind speed is very high. Where the wind speed which is generated, that is going to be very, very high. Okay, so that is what you observe in the case of this wind or the aeolian landforms. Now, when we talk about this, okay, cirque and horns are erosional landforms and eskers is depositional. That is correct. Asher written portion is not appearing on screen. Kindly refresh. Sarita, glacial valleys. Okay. Glacial valleys, my dear friend, are basically again those valley like structures. So, very briefly, I'll explain it to you about what these glacial valleys are with the help of the image. So, let's imagine a circumstance or a scenario. Let me try to create an image, even though that will be slightly difficult, but let's try to recreate an image. Let's suppose you have a mountainous area. Let's suppose. Okay. Now, here, let's assume there's a glacier which is moving. There's a glacier which is moving like this. From here, also, let's assume a glacier is coming and it is moving like this in this direction. Now, from this mountain, also, it can happen that a glacier can originate from this mountain and the ice can be falling here. Can you imagine a scenario where there will be some glacial movement here as well in this region, and then it will be falling on into the main glacier? This is your main glacier, right? Now, maybe after hundreds of years or thousands of years, when the glacier has melted, so in these areas, you will find the erosion carried out by the glacier, maybe some deposits. What about this area, which was at an elevation as compared to the rest of the glacier and where ice was coming in? Now, that is still going to exhibit a kind of an erosional structure. So here also you'll find a kind of an erosional structure, isn't it? Here also you'll find an erosional structure, a kind of a scooped out structure will be observed there. But the glacier doesn't exist anymore, so that will be a kind of a valley. So the entire region where the glacier has eroded, it forms a kind of a valley-like structure that is referred to as a glacial valley in general. So glacial valley in very simple terms is wherever you have the glacier carrying out its process of erosion and after that leaving a kind of an eroded valley-like portion, that is a glacial valley. But once we are talking about glacial valley, so here understand another concept. So here also you will have a kind of a similar valley-like structure. But then once a glacier has melted, it will be like a valley on top where no river, no stream is flowing, but a valley as if it is hanging above. So that is sometimes what is also referred to as the overhanging glacial valley or the hanging glacial valley. Okay. And anywhere where the glacier has carried out its erosion, it ends up creating a valley-like structure in general. I hope that is understood. Okay. And how big are drumlins? Drumlins are basically the size of a small hill, maybe 1 kilometer or 1.5 kilometer, 1 kilometer in its in its length. That is all. It won't be very, very large. If you think about, that is why I had put so many images here, so that you are able. So I hope you are able to see the trees here. Always understand the size with the reference of the trees. So here also, I hope you are able to look at the trees and the height of the trees and accordingly gauge an idea. Okay, right? Now, glacial till is created by the process of erosion of the rocks by the glaciers. Now, when we talk about these landforms, let us understand one basic parameter about how the wind operates or the behavior. So, if I have this as the ground surface, let's suppose I have the wind movement here. Now, as the wind is moving, you would also have experienced this, that as the wind generally ends up moving, It tends to pick the small dust particles, etc. When the wind is very strong, you would observe that it can pick large pieces of plastics, maybe a thermocol piece as well as it blows. Now, in all these cases, you would observe one basic fact, that the smaller and the finer particles, they are carried at an elevation, the very fine particles, because they are light in weight, they are light in terms of their total mass. So the wind is able to carry them at a greater height. Whereas when we talk about, let's say, the larger particles, they are carried on much closer to the ground surface. They are carried on much closer to the ground surface, isn't it? So if you have any larger rock here, let's suppose any larger rock, now if the wind is moving, now these larger particles that the wind is carrying, it will continue to hammer on these rocks, right? Very slowly and steadily, it will begin to chip away those portions of the rocks. Whereas the top portion of the rock will experience these fine particles moving. And these fine particles, just like you have a sandpaper, all of you would have seen sandpaper in your life, that when you actually rub sandpaper against any of the stone objects or rocky objects, it tends to polish them. So these wind movements, the finer particles that the wind is carrying, this will end up polishing the top surface, whereas the lower surface will get hammered, chiseled, and will get broken. So with that property, wind is able to create very distinct features in the desert rocks. Many of the regions of the desert rocks, you will find very distinctly unique features, where you will have a band like pattern created due to the polishing of that rock structure. So that keeps on happening. So here, if you take a look at it, first of all, we'll take a look at the mushroom rocks. Mushroom rocks. Now, when we talk about the mushroom rocks, they are referred to as mushroom because their shape resembles that of a mushroom. So, how are these mushroom rocks created? So, basically, they are created as the larger particles carried by the wind erodes the base, thinning out the base in the process. So, if let's suppose you have a large rock here, in this region, let's suppose you have a kind of a very large rock. Now, the wind is blowing here. The wind will carry certain larger particles, finer particles as well. Now, these larger particles, they will continue to chip here from all sides. They will continue to break this, right? From all various directions, it will continue to break this. And this process, as it continues, you will come across a scenario where this will be reduced to a shape somewhat like this. That is where the bottom portion is eroded. portion is eroded. The problem is, for majority of us, the impression and the image of the desert is created from only the movies. That is the only source of impression that we have for any desert. And in the movies, what do they show in a kind of a desert? Only sand, nothing else. So our perception of a desert is it will only consist of sand and no rocks, nothing in between. But that is not the reality. In fact, if you consider the global deserts and the entire stretch of that, the total areas where you will find such kinds of features where only sands are there and no rocks, that will be very limited. Majority of the desert landscape is dotted with large amount of rocks. It is, why is it that we refer to a region as desert? Is it basically because of the presence of sand? No. A region is a desert because of lack of rainfall. Okay. If, for example, Sahara Desert, if you take the case of Sahara Desert, it has not always been a desert. As late as around 14,000 years back, you had forests in the region, and the desertification happened later. When we talk about the Thar Desert, it was never a desert. The formation of Thar, that is the Rajasthan desert that we refer to as a Thar Desert. So that has been created as a desert very, very recently. That is why there you will find the evidence of the presence of sea as well. So, in the history of Rajasthan, in the history of the Thar Desert, that region was covered under water as well for a significant portion. So, when you think about a desert, please don't get that kind of a mentality or the imagination that where the rocks will come from. The rocks are perpetually present. The rocks are the most dominant portion. Okay. So, how is it that the sand is created? Sand is created in any particular region if the soil lacks complete moisture for a long period of time. If the soil doesn't get moisture, each of the particles will separate themselves and you will have the formation of sand. Okay. So that is where I said this, because I looked at a question that how is it that in the desert you have rocks? So in deserts originally you will have rocks. Okay, sand will be present in certain other areas. Now, what will happen eventually as this mushroom rock is getting created? What will happen after that? Now, the process of erosion will continue. Now, that process of erosion, as it continues, it will further thin this out. Eventually, the top portion will be very, very heavy, and that top portion will simply tumble down, isn't it? That top portion will simply tumble down. So, here you will have a kind of a landform where the earlier rock portion and then maybe the tumble down portion of the existing or the earlier rock which formed the mushroom. Then again, as that rock has gotten deposited here, this will also lead to the formation of another mushroom, isn't it? So this will also further break. Like that slow and steady process breaks it down, disintegrates it into many, many smaller pieces and many smaller parts. So that is how mushroom rocks are created. Okay. Now, then we have the presence of yardangs. What are yardangs? So understand the written, I will write it down first so that you have some kind of relief so that you don't panic. So, erosional structures. Yes, Vishnu, that is correct. Erosional structures created in the desert region right? That is one part. Now, what kind of erosional structure? So, wind erosion erodes the sand completely in certain areas, and when the sand is completely eroded, what will be exposed? If you remove sand from the desert, what will you come across? Will you come across mantle in that case? Will you come across asthenosphere? Or will you come across rocks? Okay, good. So we would come across the base rocks, what are referred to as parent rocks, which have given rise to the formation of that sand due to weathering and disintegration. So when the wind erodes the sand completely in certain areas, bed rocks are exposed, or base rocks are exposed. Then after that, these base rocks are eroded in the direction of wind movement, forming yardangs. I will explain you the process. But not everywhere rocks are there. Only everywhere rocks are there. Try to find a particular portion where underneath the soil or sand rocks are not there. Everywhere. The depth might vary. In certain areas, the depth might be a few meters. In certain areas, might be a couple of meters. In certain areas, maybe 20, 30 meters, but rocks will be there. It is eventually the breaking of those rocks which have created the particular soil or sand that you come across. Okay. So, how does this happen? So, imagine in a particular region, let's suppose you have the presence of all this sand. And underneath that sand, you have the base rocks. Let's assume you have the large base rocks. Now, over a period of time, due to wind action, this is the sand. Now, due to the wind action, this has been eroded. So, as this gets eroded, after some time, the level will come down. The level will come down in the sense that if you have these base rocks, then the level of sand, let's suppose, has come down to this level. And the base rocks are now exposed. So then, as the wind moves, just like observe that as the glacial movement happened, observe the streamlining that happened in the case of the drumlin, where the streamlining happened in the direction of the movement. So here also streamlining of these rocks will take place. Streamlining of these rocks, they will take place. And what you have as a creation after that, as a formation after that, that is what you refer to as yardangs. So both mushroom tables or mushroom rocks, as well as yardangs, as well as deflation hollows that we are going to take a look into next, all of them are very dominant even in Indian desert. In the region of Rajasthan desert, as you move all the way from the eastern part of Rajasthan to the western part of Rajasthan where the true desert lies, at least where the desert that you have seen in the movies, that kind of a desert lies. So that is basically where you will find the yardangs also in certain cases. In the cases, you will find the mushroom rocks also. But these yardangs, etc., they are to be found in larger quantities across the region of Sahara and across the region of the Victoria Desert. There you will find a lot of these. But in India also, you can find that in significant quantity. Then you have deflation hollows. Deflation, opposite of inflation, something which is depressed, isn't it? So when we talk about deflation hollows, this also gets created by the basic property that the wind is able to carry the lighter materials, leaving behind the heavier materials. So it is driven by that basic property. That is based on the property winds are able to carry finer particles leaving behind larger ones. So, ever if you have been on a desert safari or if you have actually walked into a desert, you would have observed that not every particle is of the same size. Few of the particles are very, very small and fine, few of the particles are comparatively larger as well. So, when we talk about the such a mixture, let's suppose here you observe the presence of coarse particles as well and the fine sand as well. So, as the wind will blow, it will be able to carry the fine sand along with it, leaving the heavier coarse particles behind. These are your coarse particles. So they will be leaving the coarse particles behind and they will be able to create a kind of a deflation hollow. Okay, wherever the fine particles were present, that has been carried by the wind. Now, all these fine particles, the sand particles, etc., that the wind is carrying, it will deposit them somewhere. And that is what the deposit in the desert that you come across, where you find the mounds of sand deposits. What are they referred to as? The mounds of sand which get deposited in the desert in general. Perfect. That is what is referred to as sand dune. So, all these eroded particles, they eventually get deposited in a kind of a mound like structure. And that is what you have as a kind of a sand dune. So, sand dune is nothing but a heap of those sand particles which have been carried, they are deposited. Now, this sand dune, it can shift owing to the direction of the wind movement, owing to the intensity of the wind movement. It can absolutely happen that if, let's suppose, there's a sand dune here. Now, this is consisted of sand, it is not compacted by any agent. So, it might happen that the wind over a period of time starts carrying this away ever so slightly, and this sand dune might get deposited here. So, the sand dunes also have a tendency to shift. Now, these sand dunes, they take various different shapes depending upon the direction of the wind movement. For example, when you have a kind of a very fixed wind movement in one direction continuously, so the dunes will also happen. So, if let's suppose the wind is moving continuously in this direction, so the wind will start dropping materials like this, and it will be linear, even though it will be like long, but the deposits will happen. These are what are referred to as the transverse dunes. And these are used by travelers, and these have been used by travelers and merchants for a long period of time, because in desert, sandstorm is one of the real threats, and many people, many caravans would be lost forever, embedded or buried under these sandstorms. So, what the travelers would do and the merchants would do in older days, they would use the shelter of these sand dunes and they would be traveling in this direction always, so that they are not exposed to the very high velocity wind movement and they would continue to travel. So, that is a transverse dune. When you have wind coming from two directions, they will start dumping materials together, and then you have what is a longitudinal formation of a dune. That is what is a longitudinal dune. Sometimes it can also happen that you have a periodic change in wind direction, or maybe winds are coming from different directions towards a particular region. So they might end up accumulating all the materials in one particular place, and you have the formation of the star dune or star shaped dune. Similarly, you can have the formation of a crescent shaped dune. How is a crescent shaped dune formed? So it is formed, let's suppose, if you have a formation of a mound or a dune like structure like this, and this portion simply slides under the weight. So you have a streamlined portion, and that is a barchan. So barchan is nothing but a crescent shaped dune which is created. So observe here. you will observe this is a barchan. This is significantly larger in size. I hope we are able to appreciate that. Now, observe here that the wind is moving in this direction. It might at one point of time had or would have caused a kind of a dune like structure, somewhat like this. Now, the top portion might have slipped off owing to the weight or instability of the sand, anything. And when the top portion would have just slipped off, it would have left behind a kind of a crescent shape with both the arms of it extending and protruding in the direction of the wind. And that is what is referred to as a barchan. So it is a crescent shaped dune, right? Where the central portion has simply slipped off. That is why this is also referred to as a slip face. And both these protrusions, they are referred to as the horns of barchans. So in all these various landforms that we have studied, guys, see, I am sure you will have different approaches to study. One of the approaches will be where few of you will be ratifying the definitions wherever you will find them, and you will by heart them, and you will try to reiterate that as many times as possible. But let me tell you, that will be a wrong approach. Don't follow that approach. In all these, if you have attended the sessions carefully, I would suggest to you that while carrying out the process of revision, which you should carry out immediately within a week, just take a look at the images. That is why this PPT has been so very image centric. I want you to take a look at the images and then try to think how this would have been created. Not only will it develop a kind of a critical thinking in your mind, it will help you whenever you are moving anywhere. It will keep that particular mindset alive where you'll be able to associate the geographical landforms around you as well, that how they could have been created. But secondly, you will never get surprised in the examination regardless of the twist in the language that UPSC frames for you. If you are able to imagine how a cirque is created, how an arete is created, how a horn is created, or how, let's suppose, a natural levy is created, how a barchan is created, if you are able to imagine that, definitions you might forget here and there. But once that visualization happens, then you will never falter. So always try to revise that with the help of visualization as much as possible. Okay. Barchans basically is when you have the a kind of a large dune like deposition and the central portion simply slips because it is sand after all. It might happen that this portion would have slipped off from here. So that is what creates a kind of a slip face and eventually a barchan. Okay. Now, after this, we come to the last form of the landforms which are created by the sea wave action. So it will be very difficult to remember this. It will be almost impossible to remember this if you try to by heart these. You should be aware of the basics that if the glacier moves, it will exert pressure on the ground. If the wind moves, wind will be able to carry finer particles on top and larger particles on the bottom. If the river moves, youthful stage will be the one where maximum erosion. So if you follow that logic, you won't be required to learn anything. And that is something I would always recommend. As much as you can minimize the portion which you need to learn, better it is. Lowest is basically the finer particles, just like in the case of river, the finer particles are referred to as silt. In the case of, let's suppose, the glaciers, the finer particles, the depositional particles, they are referred to as till or tillite. In the case of the wind, the finer particles, they are referred to as loess. And that is how these deposits in many of the regions, they end up creating loess plains. For example, the western part of China, in the Xinjiang region, you have large loess plains which have been created in the process. Okay. Yes, Gadamedi, that is correct. Now, after this, we come to the landforms developed by sea wave action. Now, seawater is salty in nature, but along with that, it has got tremendous amount of physical force. So it is due to that physical force and a combination of that chemical reaction with the salty water, where the sea wave and the sea action is able to create multiple different types of erosional and depositional landforms. One of the basic depositional landforms that you would have all observed in the case of a sea is that what we refer to as a sea beach. So, how is it that a sea beach gets created? So, think about it. When we say, let's suppose, when we say a landform like this, or that is not how a landform exists actually. Let's suppose a landform is like this, and here you have water. Now, the sea waves will consistently come crash here, will go back, will consistently then again come crash here. Now, in the process, not only will they be able to break the existing rocks, they will be able to bring some sediments here and deposit them here. So, that is how you have the formation of the sea waves or the sea beaches. And depending upon the rocks that they have broken and the deposits that they have brought, accordingly the beaches will have different kinds of. So if you have visited various beaches, you would have observed that the kind of sand particles in various beaches, they are not always the same, they are different. In certain beaches you will find that the size of sand particles are larger. In certain beaches you will find that the size of the sand particles are much smaller. Similarly, you will observe in certain beaches the color of sand particle is whitish. In certain of them, you will observe that the sand particles are brownish. That is why you have the very famous white sand beaches, and so on. So that is dependent upon the mineral composition of the rocks getting disintegrated and eventually getting deposited. So older a particular beach, finer will be the particles in that particular region in general. It is furthermore controlled by many other aspects such as the speed of the wave motion, etc. But in general, the older a beach, greater will be the amount of, or the finer will be the particles of sand. So the next time when you visit a beach, do look out for that and you will be able to understand that. Now, then let us take a look at the formation of the few of the landforms created by the sea waves. One of them is basically the sea cliff. So, what is a cliff? Cliff is where you have a sudden drop from an elevation. That is a cliff. Cliffs exist also over the land and they can exist over the coastal areas as well. When they exist over a coastal area, that is what you refer to as a sea cliff. So, here, when you talk about a formation of a sea cliff, so here you have multiple actions and events unfolding. So, for example, let's suppose I have a particular rocky region like this. Let's suppose this is where the sea waves they are present. Now that seawater, due to the wave action, will consistently be hammering here at the base, and also that seawater being salty, that will end up creating some amount of chemical weathering also. Chemical erosion will also be carried out. So after some time, what you will encounter to be found in this region is a kind of an eroded structure like this, where you have the sea being able to erode. Now, the sea will continue that process. It will continue to erode. So, after some time, after a few years, again, this will further retreat backwards. Now, what you observe here is an overhanging rock structure. That overhanging rock structure, that is what is also sometimes referred to as notch. That is what is also referred to as a notch. Now, when you think about this particular notch, which is hanging above the water, now that notch will also experience the vagaries of nature: sunshine, heating, cooling, moisture of the sea, everything. So, weathering will happen. So, weathering will happen where? In the weaker areas in order to gain stability. So, this particular portion in itself can get weathered down. So, what will you have as a result? As a consequence, you will have the portion. This also ends up falling down into the sea. So, you will have a kind of a formation somewhat like this. Right. Now, rather than a notch, you have a wall like feature. Now, again, that sea wave action will continue. Again, that process as it continues over a period of hundreds and thousands of years. Again, there will be creation of another notch like feature. I hope you are able to understand the cycle here. Another notch like feature will be created. Now, this notch will again undergo the vagaries of nature. This can again break. And what do you have at the end of it all? This will break, fall into the sea. So you will have again a vertical wall-like structure. So this vertical wall-like structure that you have, now eventually as it continues, you might come across a scenario where this recedes further and you might have the presence of a very steep wall-like feature, and that is a cliff. Okay, that is what is referred to as a sea cliff. So basically, this is your sea cliff. Generally, also to be observed in those areas where the rocks can be dissolved in sea water. Sometimes sedimentary rocks are the ones which are easily dissolved in this sea water. In India, there is one place where you do find the presence of these sea cliffs. Let me see if any of us are aware of that. Yes, Tanmay, that does mean that. Yes, it is in the region of the western coast, but where is it? Very good, Harshita and Manas. Beautiful guys. Wayanad, my dear friend, is not across the coastline. So how will you have a sea cliff if the sea is unable to reach there? Manikandan, Komal, correct, perfect. Vani, correct. So sea cliffs in India are to be observed in Varkala. Varkala. If ever you get an opportunity, you should absolutely visit that place. That is one of the most beautiful places that you come across in the country. I know that I use that terminology quite often for various parts of the country, but that is how beautiful it is. Otherwise, these sea cliffs significantly observed in the region around. When you talk about the area of Scottish Highlands, there also you will find around the region of Scotland, that is, you will find many of these sea cliffs created. Okay. Arambol is where you will find rocky formations, not exact cliff-like formations. Okay. Now, Varkala is in which state, guys? It is not Varela, it is Varkala. Good. So, sometime when you happen to plan a visit to Kerala, do visit that. Then we come across Spits and Tambolos. Now, Spits and Tambolos, according to this, the sea is becoming bigger by time. Yes, in certain areas, the sea is intruding further into the region of the land. So that can happen. In many areas, there will be deposits happening in the sea. In many areas, the land claims the sea. In many areas, the sea claims the land. So it is a kind of a consistent process. Okay. Don't get insecure that the sea is becoming larger, so we have lesser space to live in. Because if you take a look at history, the region of Rajasthan that we have now, a brief period of time in history, it was underwater. Long time back in history, even the region of Madhya Pradesh was underwater. Long time back in history, all the coastal areas that you have now was underwater. So that keeps on happening. That interchange keeps on happening. Now, this is Spits and Tambolos are what are referred to as the depositional features. These are your depositional features. Now, when we talk about spits, so deposits by the sea wave or by the wave action which tends to happen at the coastline or attached to the coastline. But then that is not all. Here, the shape of the deposit is influenced by the wind motion movement which is parallel to the coastline. What are also referred to as longshore winds. So you have the winds which blow parallel to the coastline. So as the deposits will happen, they are influenced by the wind direction, right? So these are the deposits which are carried out by the wind, by the sea waves, and then the deposits can happen in any direction. For example, the deposits could have happened in this manner as well, but they have not happened in this manner. Why? Because the shape of the deposits is very much controlled by the direction of the wind, which is parallel to the coastline. So that parallel to the coastline ensures that the deposit is linear in the direction of the coast. That is what we have as a spit. For example, if you observe this particular formation. Many of the times these spits, they can encompass or they can have a deposit for multiple kilometers. One of the longest spits that you find in the region of Europe around England, that is having a length of close to around 17 kilometers. So this is what you refer to as spits. Okay. Then what do we understand by tombolo? When we talk about a tombolo, what do we understand by that? So in many of the areas in the coastal regions, you will find that there are certain island formations very close to the land coastline, but there are like small island formations. Now in this region, as the sea wave crashes here, the speed will be very high of the sea waves. But when the sea waves come here, the speed will get slower. So the sea waves, they will start depositing material here in this region. And eventual deposition, what it does, it connects the mainland to that island. And that island is now referred to as a tied island because it has been tied when you tie something. So this is what is referred to as a tied island, not the TIDE. There's a difference in meaning between TIDE and TIED. I hope you understand that. This becomes a tied island. And this deposition connecting the mainland to the tied island, that is what is referred to as a tombolo. Okay, so for example, here that you see in the second image, at one point of time, this rocky formation that you observe, this would have been an island feature, a pure island feature. It would not have been connected to the mainland. But over a period of time, the deposits have been carried out and that has connected that. Okay, that has connected it to the mainland. So this is what is referred to as this deposition connecting the tied island to the mainland That is Tambolo. What is a tide island? Which has been connected to the mainland. That is where you say that it is a tide island. It has been tied to the mainland. Okay. Now, then after that, if you take an overview of how the sea wave operates, I I was dreading this particular question that Sommelier you have asked. I'll be very honest and very frank. I immediately I dread this kind of question. I'll read this question aloud. Uh, Ram Setu or Adams Bridge could also be said as Tambolos. So already I have told you I will not make any particular comment regarding Ram Setu, regarding Mount Kailash, regarding the city of Dwarka, regarding Bermuda Triangle. So all of those conclusions you are free to make on your own. I am too incapable an individual to make that particular comment. But having said that, in India, you do find the presence of such kind of tambolos in the region around Rameshwaram. You do find the presence of these small islands which get connected, but I don't know anything about Ram Setu, and we are all too very incapable to handle that. I hope you understand that. Okay. But UPSC also is not concerned about that. I hope that is the main point of concern. Okay. So, no, Abhishek, I say this in all the sessions. I say this in geography quite significantly because I understand once we come to the portion of Indian geography and once I start talking about the origin of various different areas, there are two questions which the candidates they will frequently ask. One is that once you are talking about Trans Himalayas, why have you not told me about the formation of Mount Kailash? And is it true that there is a heavenly body living or there is a heavenly intervention on Mount Kailash? That is where also I say that I am incapable. And secondly is about the whether there is a submerged city of Dwarka indeed or not. So in all those mythological portions, I would be very, very happy to take a back seat. I have like no idea about what has happened there. Now, coming to the portion of the other landforms which have been created in the coastal area, which you will observe in the coastal area, you will basically observe and understand this process. And in all the meanwhile, you have to understand that the sea wave, the sea water, it is salty in nature, it is saline in nature. So that salty nature many of the time will erode the rocks, and also the physical strength of the water will also be able to erode the rocks. Now in many of these cases, as the rocks get eroded, they end up carving out coastal caves, and very, very distinctly intensive or very significantly large caves are crafted. Now, sometimes it can happen that this cave can develop a connect from the other side as well. It can happen where this particular cave can have a crisscross. So in that case, the situation which will emerge is you will have a kind of an arch-like structure where the water can move in between. Okay. This is what is referred to as an arch. Now, if I ask you a question that the arch in general, the roof of the arch, now will that be stable or will that be unstable because it is exposed to weathering? What do you think? Unstable? Perfect. So this will be unstable. So this will eventually break. This will eventually break. It will fall down, isn't it? So it will eventually fall down. And then you are left with the individual structure here. That is what is referred to as a kind of a stack. That is what is referred to as a stack. Now, this stack will also experience weathering, and once it experiences weathering, its size will reduce, and that is what you have as a stump. So, all these are your various different erosional landforms which are created in the sea. Okay. How and why some water erode the land and previous form? So it can see, not in every place the sea will have the same effect, just like in the case of the wind. Not will it at every place will the wind carry out erosion or deposition only. In certain places the speed is slow, in certain places the speed is fast. So when the speed is slow, that is when it will start depositing, tying a particular island. Otherwise it will create erosional structures. Okay, so that basically brings us to the end of this particular module, this particular topic. So uh, yes. So here we take a couple of questions for the prelims perspective. Stack is basically formed, Nazarkar, as the top portion is eroded. That is how stack is created. Now here, when we talk about the particular questions, the prelims based questions, let us take the example of this question. So we have cirques, arêtes, horns, and drumlins represent which type of topography? Shruti, cirques are different from calderas, my dear friend. Yes, in a way you can say so, that the outer appearance is something which is quite similar. I expect almost all of you to get this correct. Thickness of horns and arêtes, it is not a predetermined thing. They can be of spanning a few meters in terms of their thickness. So here the answer is what? The answer is C. All of these are glacial landforms. Then again, another question I'll take. Variations in the length of daytime and nighttime from season to season, they are due to what? They are due to the Earth's rotation on its axis. This is the variation in the length of day and night. Variation in the length of day and night are due to why? Earth's rotation on its axis, then Earth's revolution around the sun in an elliptical manner, latitudinal position of the place, revolution of the Earth on a tilted axis. Lagoons and bars. So lagoons are basically the lakes, small lakes, or accumulated water bodies which are created as water hits the coastal area. So water tends to accumulate in certain regions. So that is what is a lagoon. It is a kind of a small inland lake created in the coastal region. Brief period means a small period. And when you talk about bars, bars are when the deposits happen parallel to the coastline and they are not connected to the coastline. Spits are connected to the coastline, bars are not connected to the coastline. So here, again, good. Majority of you have given the correct answer. That is revolution of the earth on a tilted axis. It is because the earth is tilted on its axis. That is why different portions get different amount of exposure to sunshine. Okay. Beaches are created as a result of deposits. As the sea waves, they start depositing materials. That is how they end up creating beaches. Arches upper part is eroded. The roof is eroded in the case of an arch, and then you have a stack, and then stack is weathered, and then you have a stump. Okay, uh, right now. After this, we will be moving on. We will be discussing these questions at the end of the session. Before that, we will be moving on into the portion of climatology. So let's take a break and we'll take a break for 15 minutes and we'll be back and then we will continue with this portion. have in a desert area, let's suppose you consider a region where there has been a significant amount of erosion, generally associated in a valley kind of a portion. So there, that erosion ends up creating that playas. Now, playas, many of the times you will have exposure of the groundwater as well, which is referred to as a playa lake. Okay. And when you talk about the uh, pediplains, pediplains are basically those kinds of final features of degradation or erosion, where erosion has reduced the various different landforms, and they have been reduced to almost a flattish portion with few individual monadnocks emerging here and there. That is what is pediplane. But all these are not relevant for your general studies in general. That is why we have not covered them. They are something which is asked in the optional portion. Okay. Yardangs and mushroom rocks, will they be formed separately or simultaneous? They are formed separately. Like if yardangs created, then after so many years of erosion, it, yes, so a yardang can end up getting formed into a kind of a mushroom rock. Okay, yardang benica is when you have the base rocks which are exposed, and those base rocks are then eroded and streamlined based upon the direction of the wind. Cliff formation is when you have a sea wave action. In the case of a coastal cliff or a sea cliff, when we talk about land, in the land area, cliffs can be created due to multiple events of weathering, erosion, etc. But in the coastal area, the cliffs are created when you have the sea wave action eroding the rocks continuously, and the top portion of the rocks which overhangs also breaks up. So that is where you have almost a vertical wall like structure. Okay. And alluvium is carried by the river, till is carried by the glacier. Okay. Barchans, Gauri, they are the crescent shaped dunes. They are, in simple terms, they are sand dunes, but just their formation or the shape that they acquire is that of a crescent shape. What type of questions can be framed on the cliffs? Just like for any other feature, any question can be framed almost similarly. Okay. So, having said that, can mushroom rocks be created in coastal areas due to wind movement? No, because there the wind movement is over the seas, they are strong. But when you talk about the rock like structure, you won't have enough amount of erosional or chipping power to break the rocks from the lower portion. So now we start with the portion of climatology, and we start with the discussion of the very basics of atmosphere and temperature. Now, this is a particular area which has always been very important for your examination. Climatology in total as a module is something very, very important for your portion of examination, because understand that when we talk about climate of a region has got a far reaching impact and effect. Climate of a region does influence the kind of, let's say, the plants which will grow in that area, the kind of biodiversity that you find in an area. It will also end up influencing, when we talk about the plants, it will also influence the type of crops that will grow in an area. Also, it will determine the kind of food that you consume, the kind of clothing and the shelter and the shape of the houses that you have. So all of that is determined by the climate of a particular region. That is why climate is considered to be very, very important. Now, in this particular module or the unit of climate, we shall be starting from the very, very basics. We shall be starting from the basics regarding the formation of atmosphere in itself. Just like in the case of geomorphology, there we looked at the formation of planet Earth. Here also, we shall be looking at the formation of atmosphere. We shall try to understand the very basics regarding something that you have already studied up till your class 10th level and 10th standard. What do you understand by convection, conduction, radiation? How is it that temperature induces a change? How is it that the temperature changes when you go from one region to another? Then, after that, we will be talking about the factors, for example, the wind movement. Why is it that the wind comes into existence? Once or if a wind comes into existence, what are the various factors which end up influencing the direction of the wind or the speed of the wind? Once we have understood that, then we will then graduate into slightly complex phenomena such as formation of a cyclone, occurrence of rainfall, formation of a cloud, the different types of cloud. And once we have done this, then we will move ahead into the atmospheric phenomena such as jet streams, El Nino, La Nina conditions, El Nino Modoki, also Indian Ocean dipole. What are these? Madden-Julian oscillation, jet streams. And a knowledge and information of all of this will help us understand Indian monsoon. So all that climatic factors that UPSC wants you to study, it is primarily to help you understand India's climate in a better way. Because India's climatic condition that you experience from north to south, from east to west, is as distinct and varied as it can get. So that is why, in order to understand that, you need to have an idea about the various factors influencing the climate. So, from this particular module, this is the first module of climatology. So, in this particular module, the portions which are relevant for prelims, even this year, you had two direct questions which were asked directly from what we will be discussing in the PPT. So, for the portion of prelims, evolution of atmosphere has been asked once, so let's write that as well. Evolution of atmosphere. Do we need to study the NCRTs? I would always suggest you to go through NCRTs at least once. It will be for a process of revision, but once you have been attentive in the sessions, which many of you have been, you won't find it difficult, trust me. But if you let a lot of time pass between once we have covered geomorphology or once we have covered a portion and then you pick up NCRT, it might be a different proposition altogether. So I would always suggest to you that after we cover a particular larger unit such as geomorphology or climatology or oceanography, cover it up with the portion of the NCRTs. That will not only provide you with a level of confidence, which is very much required in this examination, it will also provide a universal coverage, which is the eventual aim. All the toppers that you talk to, the serious ones, right? Not the ones who, after they come out of the exam hall, they will tell you that I have read all the books in the world, but indeed they have not. So if you talk to the sincere people, all of them, they will tell you that for geography, they basically relied upon the portion of the NCRTs along with the current affairs. So once you attend these lectures, trust me, and any of you who have been studying NCRTs, you will realize that we have taken the level of discussion to such a point where NCRTs are something very easy to understand. In many of the portions, we have increased the level of discussion to the point of even the optional area. So coverage of NCRTs won't be a difficult point at all. So once you have covered everything, I can put it in guarantee that if you have been attentive in the classes, covering the entire 11th and 12th NCRT will take not more than 10 days. But don't think about it that, okay, it will take me 10 days, so I will devote those 10 days in February. Right now, let's chill out. Don't have that approach, because in that case, it will take you 40 days. So don't push it up. Okay. So evolution of atmosphere, then composition of atmosphere, basics of lapse rate, heating of basics of heating and temperature, and temperature. Then after that, we will be covering, or the portion which is asked in exams quite often, is about the factor of temperature inversion. Okay. Whereas when we talk about the mains portion, frequent questions in the mains examination are also asked from this topic, from this particular area. So layers of atmosphere, that will be added here as well. Layers of atmosphere. Then after that, we also have questions coming from urban heat islands. Mayank, class 11th and 12th NCRT. If you are unable to understand that, then go for 6th or 7th. I hope that you will be able to understand class 11th NCRT very easily. Then heating and insulation. Then after that, you have the portion of temperature inversion, which has frequently been asked. So you can imagine the importance of climatology, where from the basic first module that we are going to cover, these many topics are relevant and are frequently asked by UPSC. So you can gauge an idea about how important and relevant this is going to be. So here, in this particular module, we will be discussing about what do we mean when we talk about the atmosphere. What is it that the atmosphere is actually made up of? And furthermore, we will be developing that concept to understand how is it that the heating happens, whether the heating happens at an equal rate in all the different areas, or whether there is a kind of a differential heating which is experienced in different areas. All those factors we are going to address in this case. Okay. Now, I hope everybody is fine with that. I recover the feeling of underestimate while reading NCRT. Okay. NCRT, please don't worry about it. It is written in a very light manner, and don't be afraid of NCRT. Okay, don't. It is something which is written in a very easy manner. Because think about it, NCRTs have been written for class 10th, 12th students. Obviously, by now your level of understanding would have improved much more. Class 11th and 12th have geography as a subject in this. Yes, yes, that will be more than sufficient. 11th or 12th NCRTs or Byju's book, any of them you can go through. Any of them. Byju's book also is basically derived from the portion of the NCRTs. Okay? Right? Now, after this, let us start with the concept of atmosphere. So, what do we mean when we talk about atmosphere? Atmosphere is the air, a blanket of air, an envelope of air, which surrounds the Earth's surface. That is what we refer to as the atmosphere. So it is kind of a large envelope of air surrounding the surface. Now, air is something that we don't end up feeling on a daily basis. Whichever room you are sitting in right now, it is filled with air. But you won't be able to feel that unless and until you switch on a fan or you switch on a cooler or an AC. Unless and until that happens, you won't be able to feel that. So it is only the movement of air that we are able to perceive. But air in specific quantity or in specific material, we are not able to experience that. Now, the air which is present near the ground surface, that is the start of the atmosphere, and the atmosphere extends for thousands of kilometers. Now, as the atmosphere goes on over a particular distance, the particles, the molecules which contain or which are present in that atmosphere, those molecules, they start becoming lesser in number. Eventually, there is no fixed limit that this is the end of atmosphere. The atmosphere keeps on thinning out so significantly till eventually it mingles with the outer space. That is the case of atmosphere. So always understand that atmosphere is a mixture of gases, various different gases, which provide life on the planet Earth as well. And all these gases, where is it that the maximum density of gases will be found? The maximum density of the gases will be found closest to the Earth's surface. Why? Because of gravitational pull of attraction, right? So that is where you will have the maximum density of the gases. So maximum density of gases closest to the surface. And why is that? That is because influenced by the gravitational pull of Earth. So, all the various components of atmosphere that you have will be found in maximum quantity closest to the ground surface. Now, here, the atmosphere that we live in today, the atmosphere that we breathe in, that consists of close to around 78 to 79% of nitrogen, close to around 21% of oxygen. It is that oxygen which allows us to breathe. It is that oxygen which allows us to carry out respiration and allows us to live. So, has the atmosphere always been like this? Or has the atmosphere actually changed over a period of time? So, basically, at the time when the planet was getting created, the atmospheric makeup was very, very different. And as the planet has evolved, so has the atmosphere. In fact, the oxygen that you find today, that oxygen is one of the latest entrants or additions into the atmosphere, which happened close to around 400 to 500 million years back. That is when the atmosphere suddenly started having an increased concentration of oxygen. So when we talk about the evolution of atmosphere, it can be basically classified into various different stages. The first stage overall is what is the primordial atmosphere. Primordial is basically a very primitive form of atmosphere. That is primordial. Primordial refers to anything which is very primitive. So, this is when the planet was still in a molten state, in a liquid ball. So, at that point of time, right, here you had the atmosphere consisted of hydrogen, lighter gases, hydrogen and helium. Hydrogen and helium, which were the lightest of the gases, they were the chief components of atmosphere earlier on. Now, at that point of time, even Earth was not stable, the solar system was not stable. You had frequent solar discharges, solar winds which would come, and they would strip off that hydrogen and helium, which were anyways very light, and they would be stripped off. But then a major change happened in the Earth's atmospheric setup as the planet was evolving. I hope we are able to recall that there was a phase which we refer to as the phase of degasification. So, I hope we recall that in the evolution of the planet. So, that phase of degasification, when it happened, that brought about major changes in the planet's atmosphere. So, this is when the new gases they found their presence. So, during the phase of degasification. So, in this particular phase, you had gases like ammonia, carbon dioxide, carbon monoxide, hydrogen, sulfur dioxide, water vapor, etc. These were introduced. Here also you'll find that individual oxygen molecule is not mentioned here because still at this point of time, oxygen was not a dominant molecule in the Earth's atmosphere. But nitrogen, however, was introduced at this point of time itself. And that nitrogen has remained consistent over that particular period of time, and over the ages nitrogen in the atmosphere has remained consistent, where all the other gases and their proportions have varied. Why is it so? That is because when we talk about nitrogen in its elemental state, now nitrogen in its elemental state is not very reactive. Carbon dioxide is very reactive. It will form carbonates very easily with any rock surface that carbon dioxide interacts with. It will form a carbonate if the rock allows it. Oxygen is also very reactive. It will easily form oxide. That is why oxygen is the abundant element on the Earth's surface. It will readily react. But nitrogen does not readily react. It is quite inert in that way. That is why, while the proportion of the other gases have increased or reduced over the period of the ages, nitrogen has remained consistent. Now, that leads us to other important concept, which we will study in the portion of biogeography and Indian geography later on. But it is derived from this particular part, and that is because nitrogen as a gas is not very reactive, it is largely inert. That means it won't be able to form various nitrates of the rocks. It won't be able to interact with various rocks. So, the surface rocks that you find on the planet, because nitrogen is one of those gas which does not react readily, the surface rocks, they are poorer in nitrogen always. Why? Because the nitrogen in the air does not react readily with the surface rocks. So, the surface rocks are poorer in nitrogen. And when the surface rocks are poorer in nitrogen, when these rocks will disintegrate and weather to form soil, will that soil have nitrogen? No. So that is why almost all the soil types that you find across the world, almost all of them, they are found to be deficient in nitrogen. Okay. Even when we talk about the different types of soil that you find in India, that is what we will study in slightly greater detail later on. But that is the case with the entirety of the world. Almost all the soil types, they are very, very poor in nitrogen. Why? Because nitrogen in itself is not very reactive. Okay. Now, having said that, once the evolution of these new gases happened, now carbon dioxide was one of those gases which was present in significant quantity. And that is when, once the genesis of life happened underneath the oceans, it was basically the blue green bacterium which came into existence, or cyanobacterium which came into existence, which utilized the carbon dioxide around them, carried out the oxidation of that carbon dioxide, and was able to produce energy and sufficient nutrients. So there was initiated a process of photosynthesis in a way, in a slight manner. Plants also came into existence. So when the plants came into existence, why did the plants come into existence in such a major way? Because carbon dioxide was available in significant quantity. So, with the onset of these plants, the plants started growing at a tremendous pace. All these plants, they carried out photosynthesis. And in the process of photosynthesis, the byproduct is oxygen. So, that is how you have the production of oxygen eventually taking place. So, here, basically, with the evolution of plants, photosynthesis became prominent. And when that became prominent, oxygen was produced. Since that point in time, the quantity of oxygen kept on increasing and the quantity of carbon dioxide kept on reducing. Since that point of time, continuously the quantity of oxygen has been increasing. So, I will not go into significantly greater detail about it, but the history of the planet, it is said that it has gone through two phases of oxygenation, where significant quantity of oxygen has been added. And the last phase of oxygenation, which happened, was close to around 400 to 500 million years back. And it is in that phase when suddenly oxygen and the quantity of oxygen started coming in larger quantities. That is when the life forms on the planet, the complex life forms, they started developing. Multicellular organisms, they started increasing tremendously. Very evolved body structures started coming into existence tremendously. So that is how eventually you had the creation of very large organisms at that point of time. Earlier also, I hope you would be aware, otherwise also, that if you take a look at the size of the organisms, maybe 300 million years back or 200 million years back, they were much, much larger. And all of that was because of the sudden oxygenation of the atmosphere. So that is how oxygen is one of the latest entrants. Now, UPSC has framed a question from this in the prelims earlier. It was a part of a multi statement question. And I'll tell you how simple the question was. The question statement was that the presence of oxygen in the atmosphere has remained consistent throughout the history of the planet. Now, if you know even the basics of the evolution, you would basically be able to distinguish that that is not the case. Okay, so oxygen is the latest entrant. Okay, in the meanwhile, a couple of you have consistently been asking whether it is compulsory to read NCRT. Okay. So I hope all of you who are asking that question, you have understood this portion of evolution of atmosphere, because I hope you have not put that into doubt just because of that simple question whether it is necessary to read NCRT. I'll tell you the basics. Understand it. Okay, about what books to read, what books not to read, etc. Try to open up your mind and try to listen in. First of all, there is no set prescription given by UPSC that I will ask questions from this book. Get that thing very clear in your mind. So that means there is no designated book list that from here only questions will be asked. If you have not read this book, you are out there left to dry on your own. That is not going to be the case ever at all. Secondly, what is it that is required to be covered for the point of examination? The coverage of basic concepts along with the portion of current affairs, right? That is understood. Now, for the portion of the basic concepts, that is why we have the classes. That is why we have the tablet recordings for those basic concepts. But in order to revise them, you need to study certain books also. Books will always help you revise better, right? You have a point of reference. Having said that, I'll tell you how is it that the candidates generally they change their form also. I'll come to that later. Why is it that I suggest to you that refer one basic book, be it the NCRT, be it the Byju's book if you have that, any of the basic book if you refer, it gives you a point of reference, that what is it that the book is talking about, whether I know more than that, whether I know less than that. Why I am telling you NCRT is because that is what the UPSC suggests, that class 10th level information you should have. 10th or 12th level information is something you should have. So the world reads NCRT. Just so that you are not left out of the process, I am suggesting you that. If you have attended the sessions carefully, you have covered the PPT, you have covered the additional reading materials, you have revised with the tablet lectures, you can ignore the NCRTs completely. I will tell that as well. So if you have covered the basic, the portion of the classes, the PPTs, the additional reading materials, and the tablet videos, and then you have covered the current affairs, no need to cover the NCRT. If in any of these areas you are lacking, NCRT is a kind of a compilation of sorts. Okay, so flip through or browse through the NCRTs in that case. Now, whenever I take the first class, most of the candidates they ask me that I will be studying the classes, the PPTs, plus the NCRTs, plus the additional reading materials, plus the tablet. Will that be sufficient? I say it is sufficient. After a week, the questions that start coming in, I will be reading only the class PPTs, plus the additional reading materials, plus current affairs. Will that be sufficient? In that case, also, I say it is sufficient. Trust me, from next week, I will get questions, and that has been my experience, that I will be studying only the class PPTs. Will that be sufficient? Obviously, in that case, I'll tell you that take care of some or the other reference book. Okay, so try to understand what is required for the examination. This is not a kind of your 10th board examination where you have a sample paper, questions will be asked from there itself. So I'm trying to give you the maximum amount of confidence that you can gain. Again, I will repeat, if you are thorough in the class, you have understood the portions of the class concepts along with the additional reading materials, along with a revision from the tablet, you can ignore the NCRT. Is that understood? Is that understood now? Or is there a doubt which still prevails? Understood? Any doubt that you have regarding the materials which need to be covered? I have covered it in the first session itself. I had multiple questions about the books. Ushasri, is that understood now? Good. Now, can we continue then? Good. If the Byju's book you have not received, don't worry about it. Read the NCRTs in that case, if you want to read a book. Okay? If you have received the Byju's book, read the Byju's book. If you have if you don't want to study any book as of now, just read the class PPTs and pay attention to the class. I hope that much you can do. Okay? Questions in between the PPT for practice. Take the questions, the PYQs that we have been discussing. Practice that for writing. More than sufficient, my dear friend. Okay. Now, can we proceed? Okay, good. So, we were talking about the evolution of the atmosphere. Evolution of atmosphere has happened over a period of time. What the composition of atmosphere that you found earlier around 4 billion years back, the composition of the atmosphere today is completely different, right? And you have to understand that how this process has happened ever so slowly. So initially you had the presence of only light gases. They were replaced by the heavier gases. When you came across the phase of degasification, many of the heavier gases came into existence. And then eventually the atmosphere was modified. Okay. Now, here, yes, Monica, that is also sufficient. Okay. See, I won't be taking each of your names individually. I hope you understand the larger context that I'm trying to put forward with the case of resources. If you still have any doubt, my dear friends, please take a look at the recording of the first lecture. I have talked about the resources in significant detail. Okay, current affairs from newspaper. Okay, old NCRTs. As of now, Dhanya, just pay attention in the class. PPTs, trust me, just wait for some time. In PPTs, we have covered the portions which you will not find in many of the books. Even if you are regularly following any NCRT or any state book, as Vivek, you are pointing out, trust me, after a few modules, you will not be able to find the portions that we are discussing in the classes in those books. And that is something which is relevant for your examination. So trust the process. After 24 sessions, if you still have doubt, I am there for you. But till 24 modules, I will ask for a basic level of trust and a basic level of patience. Okay? I hope that is something that I can have from you. Anurag, I tried to search it out. I did not find it. So again, I will tell you, send a reminder if you will be kind enough. Now, now we come to the portion of composition of the atmosphere. Here, what is it that the atmosphere is composed of? So, when we talk about the atmosphere and atmospheric composition, it is basically made up of various different things, such as various different gases. It has got the presence of water vapor, which is also a kind of a gas. But water vapor has got such a distinct role to play. And it is not one of those gases that we breathe in, breathe out. So that is why it is distinguished from the rest of the gases. And then you also have the presence of dust particles. All of these components in the atmosphere, they have their own distinct role to play in terms of influencing the life on planet Earth. That is why planet Earth is considered to be so very unique. It is not as if other planets won't have atmosphere. They will also have atmosphere, dependent on and a byproduct of their gravitational pull of attraction. They will also have an atmosphere. But in planet Earth, you have the perfect conditions to breed or to give rise to carbon based organisms. We all are carbon based organisms. Plants are carbon based organisms. Animals are carbon based organisms. So, on planet Earth, you have the perfect condition for those carbon based organisms. So, let us take a look at the role played by all of these components of the atmosphere. Now, before that, any of us who has no clue about what is greenhouse effect, or and feel free to ask that. Don't worry about it. Or do we understand the greenhouse effect? Okay, fair enough. Let's talk about the concept of greenhouse effect. In case you know, take it as a point of revision. So, the concept greenhouse, how did it come into existence? How is it that this concept or this naming greenhouse, how did it come into existence? So, we will get into that, the details of that. But before that, I want to indulge you in a kind of a basic aspect about the property of heat and the transmission of heat. And that is where we will be studying about wavelengths. What is a wavelength? Wavelength is the length of a wave. As simple as that. Length of a wave, also represented by the term lambda, which is a Greek alphabet basically. Now, any object which is hot will emit energy. Always. Any object which is hot will emit energy. If ever you have basically tried it out, if you see, or I'm sure you would have observed this, if you have a very strong halogen light, now if you stand in front of it, you'll feel some amount of heat. Or take the case of the older bulbs, not the CFL lamps that you have nowadays. The older bulbs, the yellow ones. Now, those yellow ones, if you would continue to light it for some time, it would get very, very hot. If you can recall, I don't know how many of you would have seen that, but I'm sure some or the other place you would have witnessed that. So, any object which is hot will release energy. Now, hotter the object, greater is the energy released. Colder the object, lesser will be the energy released. That is one of the key points that you have to understand. Any object which is hot releases energy. Hotter the object, higher energy is released, is the energy released. And the vice versa will also be true. Right? Now, here, how is it that the energy is released? Energy is released and energy is transmitted in the form of a wave like format, isn't it? So, here, energy is released in the form of waves. Now, let's suppose we talk about a particular object which is very hot. Now that releases, this has, let's suppose, very high temperature. Temperature is very, very high. So in that case, it will release lot of energy. High energy is released. Of energy will be released. Now, when the amount of energy released is very, very high, it will be, the waves will continuously be pushed in, isn't it? Let's suppose an object A has got very large amount of energy that it will release. It will consistently keep on releasing energy endlessly. Whereas an object B which has got lesser energy, it will release energy slowly and steadily, isn't it? So here, when you have very high amount of energy which is released, it will be released in the form where the wavelength will be smaller. Or rather than taking such a large one, let's take the case of a smaller one. High amount of energy is released. Right? Why? Because consistently that energy is being pounded from that hot object. Now, what can you say about the wavelength of this? The wavelength is less, isn't it? The wavelength is less here. Now, let us consider another object where it is cooler. Cooler in comparison, not cold per se, but cooler in comparison. So if the earlier object's temperature, let's suppose, is 5000 degrees Celsius, here the temperature is 50 degrees Celsius. So considerably cooler, but 50 degrees Celsius is also a significant temperature. So it will release less amount of energy. And when that less amount of energy is released, it will be released at a greater time, right? Frequency will be, or let's not enter into the term frequency at all. Basically, it will be released very slowly, very easily, consistently, it will be released. So what you will have is a kind of a wavelength somewhat like that. So where the wavelength will be very high, right? These are what are referred to as short waves. And these are referred to as long waves. Now, short waves will always have high energy level. This will have lesser energy. Okay. Now, with this basic, let us come into the portion of greenhouse effect. So how is it that this entire concept of greenhouse that was developed, and why it is named as greenhouse? Why not a brown house? Why not a white house? Why only a greenhouse? This is because in the higher latitudes, sometime back, in the region of the higher latitudes, agricultural growth could not be furnished or could not be carried out. Agricultural production could not be carried out because in the higher latitudes, in the region of Northern Europe, Northern America, the temperature would get so very low that you would have a scenario that during nighttime, all that heat would escape from the surface and the plants would die of frost. That was the condition because the nighttime temperature would be so very low. So, what was devised was a kind of a glass house, a kind of a glass house structure. This glass house was devised. Now, as per this glass house, what it would do is you would grow plants in that glass enclosure. Even today, you find it in many areas that this is a methodology which is being used very frequently. But once it was conceptualized, it changed the lives of the farmers. Why? Because glass has a property where it would allow the shortwave radiation of the sun to penetrate through. But then the heat would be trapped inside. The heat would not be allowed to escape. So, by that, the temperature could be maintained inside it. And that would allow the growth of the plants. Because it would facilitate the growth of plants and crops, hence the name green. And because it would be a glass house enclosure, hence the name house. That is where you had the entire concept of greenhouse. Something on the similar proportion you would have observed even in the case of any car that you travel, any vehicle that you travel. Now, if you roll up all the windows, leave it out in the sun, after let's say half an hour or 1 hour when you enter the car, it is much more hotter than the surrounding temperature. Why? Because as you have rolled up the windows, it has allowed the heat to come in, but that heat cannot escape anymore. Similarly, let's suppose you have a kind of a, in your room, you have the glass windows where the sunlight can come through. So do one thing, lock your door, don't allow or don't switch on the fan. Lock your door, go outside for some time, and don't open the windows. Just allow the glass to be there. You will observe that after you come back in an hour or so, that glass would have allowed the heat to come in but would not have allowed the heat to escape. And that is why it would become hotter. So it is that greenhouse effect. So, on what basis does it function? It functions on a very simple basis that the temperature of the sun is very extraordinarily high. Sun is very, very hot. So, when the sun is very hot, will it release the short wave or long wave radiation? What do you think? Will it release the short wave or the long wave? Always short wave. So it will, because the sun has got very high amount of energy, it will end up releasing short wave radiation. Now that short wave radiation, because it has got very high amount of energy, it will simply pass through the air. It will be able to penetrate through all the thickness of atmosphere. But upon hitting the surface, that short wave will end up, or that rays of the sun will end up heating the earth's surface as well, isn't it? That will end up heating the, so in any region when the solar rays fall for a long time, they will heat up that region as well. Now once that region is heated, now it will also act as a hot object, it will also act as a hot body. So here, once the planet earth, let's suppose, gets heated, any portion which is exposed to the sun, if that gets heated, so that will also start emitting radiation. But there, will it emit radiation at the same quantity as the sun, or will it emit radiation of a lesser amount of energy? Always lesser energy, isn't it? Earlier, we have seen that if the temperature is very high, you have short wave. If the temperature is less amount of energy, long wave. So long wave has got lesser amount of energy. So after the planet gets heated, the temperature is around 40, in certain areas maybe 45, certain exceptional regions maybe 50. But overall 30 to 40 or 45 is the temperature. So that heat will be emitted by the earth in the form of long wave radiation. So that earth will start emitting long wave radiation. This will be your incoming short wave. Short wave radiation. Now, once it heats up the surface, that will be heating up, or that heat will be emitted, and it will Basically, some portion of that long wave might escape, but the atmosphere, it will trap that, just like the glass. It will trap this, it will not allow it to pass. Why? Why will the atmosphere not allow it to pass? Because this long wave has got a very low level of energy. So when the energy level is low, it won't be able to penetrate the atmosphere. So it will be re-radiated back, again heating the surface, again getting reflected, again re-radiated back. So with this, just like in the case of the greenhouse, here also the temperature will be maintained. And that is what is the greenhouse effect primarily. So here, long wave radiation. Now, this long wave is being emitted from the Earth's surface. After the Earth's surface gets heated up, that is when this long wave is getting emitted. So that is why this is also what is referred to as the long wave terrestrial radiation. It is not allowed to pass through the atmosphere. Why? Because this has got a very low energy level. Very low energy level. Hence, cannot pass through the atmosphere. If the energy level is high, they will be able to penetrate the atmosphere. So some amount of long wave is able to percolate through, but majority of them are trapped. Just like in the case of the glass. In the case of the glass also, the incoming radiation would be the shortwave solar radiation. They would be able to penetrate through it. And as they would heat up the interior of that glass house or the greenhouse, the temperature in the interior would be around 40, 45 degrees Celsius, 35 degrees Celsius. So they would start emitting long wave, and that long wave would be stopped by the glass. Why? Because you have the lower energy level. So any wave, any kind of radiation, depending upon the energy level, that is when it is allowed to pass through or not allowed to pass through. So as this heat is retained, as this terrestrial irradiation is retained, the heat is retained in the atmosphere, and that is what is referred to as greenhouse effect. Okay, that is what is referred to as a greenhouse effect. Now, ideally, with this, if you think about it, is it beneficial for the planet or is it harmful for the planet? The problem is nowadays, wherever you hear about the greenhouse effect, you hear about it that it is detrimental to the planet. But it is beneficial. For planet Earth, it is beneficial. Why? In majority of the planets where the atmosphere is not very dense, you come across a very peculiar scenario where during the daytime the temperature is very high, and during the night time the region which is away from the sun, that becomes very cold. So during the daytime the temperature might increase in certain areas to 100, 120 degrees Celsius, and during night time it might decrease to minus 100, minus 150 degrees Celsius, because there is nothing holding that heat. Here, what do we experience on the planet? If the daytime temperature is close to around, let's suppose, 40 degree, 45 degrees Celsius, by night time we expect a temperature again of 25, 30 or 35 degrees Celsius. There's a maintenance of temperature. Why? Even if that is not facing the sun, it is able to retain heat. That is why the temperature is maintained. So that is a feature where the greenhouse effect is beneficial. Okay. So here, let us talk about the entire process. I will recap it. very briefly. So, when we talk about any object which is hotter, any hot object will emit significant amount of energy, and that energy travels in the form of waves. Hotter the object, greater is the amount of energy which is transmitted. When you have higher amount of energy transmitted, energy will be released continuously, and you have a short wave radiation which is accompanying that. An object which is cooler, an object which is comparatively cooler, that will release lesser amount of energy, and that is where you have the energy released very easily, and that is a long wave. So that is the concept of short wave and long wave radiation. Now, having said that, when we talk about the planet Earth, now planet Earth receives its heat from the sun. Now the sun, because it is very very hot, thousands of degrees Celsius, it releases short wave radiation. Now, that short wave radiation has got such a high amount of energy, it will easily be able to penetrate through and push through the atmosphere. Upon hitting the Earth's surface, it will start heating the Earth's surface as well. Now, as the Earth's surface is heated, it also starts behaving like a hot object, but not on the same terms as the sun, because the Earth's temperature would be at max around 40-50 degrees Celsius on the surface, whereas in the case of the sun, it would be 2000-3000 degrees Celsius. So Earth releases energy, but that energy is not significant. So it releases energy in the form of long wave, what is also referred to as the long wave terrestrial radiation. Now, that long wave terrestrial radiation, because the energy level is low, it is reflected and retained by the atmosphere. And that heat ensures maintenance of temperature even during nighttime. So, this greenhouse effect, it has got ability to maintain temperature during night. Now, which are the gases in the atmosphere which allow the atmosphere to retain this long wave radiation? You have various different gases, from carbon dioxide to sulfur hexafluoride to even water vapor to nitrous oxide to methane to carbon monoxide to sulfur dioxide. All the various different gases which are present, they allow to retain heat. Some amount of heat is able to escape, but majority is retained. Now, why is it that nowadays, whenever you hear that the greenhouse effect is increasing, it is always in a bad manner, or it is always in a detrimental term? That is because, with ever since the industrial revolution has happened, so we have talked about the fact in the evolution of atmosphere, that how since the past few 100 million years, the planet has been going through a phase where the proportion of oxygen has been increasing and the proportion of carbon dioxide has been reducing. Ever since the industrial revolution happened, this process has been appended a bit, where the amount of carbon dioxide in the atmosphere through the various industrial emissions, vehicular emissions, etc., the amount of carbon dioxide and such different greenhouse gases, that has been increasing in the atmosphere at an exponential pace. So once that is to be found in increased quantity into the atmosphere, it will not allow any heat to escape the Earth's atmosphere. All that heat will be retained. So Earth, in a way, is getting converted into a like a hot chamber, where all that heat is basically retained within the planet. And that is why that is leading to increased amount of warming, which is referred to as global warming. Okay. Now, after this, we come to the composition of the atmosphere and the role played by each of them. So, when we talk about the presence of gases and the role played by gases, gases here will include carbon dioxide, oxygen, nitrogen dioxide, argon, etc. So, these gases, they play multifarious roles. One of the role is they can be considered to be as a provider of life, provide respiration, and hence support life on the planet. Then, after that, you have another role that they play, and that is by greenhouse effect. They help retain the heat even during night. After all, I won't digress very much into it, but I'm sure all of you would be very much interested into the aspect of SpaceX and Elon Musk's plan and the entire of the scientific community's plan to colonize Mars, to bring life back into Mars. I'm sure you would be following that. Now, in the case of the Mars or the planet Mars, what is the major problem that we are facing? We have all the basic molecules which can support life. But the major problem that we are facing is, and Mars also has indicated the presence of the potholes that we studied in the case of fluvial erosion, all of that is present in the case of the Mars. So the problem is there is not enough heat. Heat is not being retained. So how will that heat be retained? If you pump in enough amount of gases such as carbon dioxide, that heat of the sun will be retained. That is why there has been a kind of Elon Musk actually put it forward in one of the talk shows where he said that we can do this with the help of bombing Mars with nuclear bombs so that enough heat is produced and then that heat will be retained and then you will have the presence of liquid water as well. Then after that the atmosphere can be evolved. So that maintenance of heat is a major problem in order to support life, and that is provided by the gases here. Okay, now then, when we talk about water vapor here, yes, Muskan, Earth's atmosphere in this case acts like a glass. So here, when we talk about water vapor, so all the various events of rainfall, cyclones, various different events of thunderstorms, typhoons, or tornadoes, anything that you come across, cloud formation, that is initiated by the presence of water vapor. If you were to, let's say, condense all the water vapor present in the atmosphere, it would not be very significant. It would be less than around 1 inch thickness on the planet's surface. Think about it. All the water vapor present in the entirety of the atmosphere, if it is condensed, it will be not even more than 1 inch thickness. That is how limited water vapor is present. But then, even that is more than sufficient to bring about climatic actions. So, climatic actions such as rainfall, cyclones, etc. Then, water vapor, by the way, that also ends up acting like a greenhouse gas. So, this water vapor also acts as a greenhouse gas. Okay. Then, after that, we have the dust particles. Now, by the way, majority of the water vapor and dust particles and majority of the gases, almost 80% to 90% of the mass of the atmosphere is restricted within 20 kilometers from the Earth's surface. So you can imagine the density of the air that you and I we are living in. So that is why when you move up, higher up, you need special space suits. You need the support systems, right? Because all the gases, majority of them are hugging the Earth's surface. Now, here, How water vapor acts as the greenhouse gas? Because it is able to retain heat by retaining that long wave radiation. Dust particles, they play multiple roles. One of the important role that it plays is it scatters sunlight, and then it traps some amount of sunlight and gives away that light during the night time. So many of the times during the darkest of the nights, when you don't have, let's say, you don't have any artificial lights anywhere near, you don't have the light of the moon, you don't have the light of the stars, still it is absolutely dark, still you would feel or you would observe that you are able to figure out whether it is a tree, whether it is a road that you're walking on, or whether you are actually where you are moving. You are able to figure out the broader contours. How is it so, or why is it so? If there is no source of light, that is the diffused light. So basically, in the atmosphere, you have huge amount of dust particles, huge amount of dust particles. Now, these dust particles, what they do? They will scatter the sunlight. Some amount of sunlight will be trapped within them. Okay. And that sunlight is given out during the night as diffused light, which allows us to see even during the darkest of the nights. So, by scattering light, yes, that is the Tyndall effect, but let's not confuse other people here. So, by scattering solar rays, some amount of light is trapped, which is emitted as diffused light during the night, allowing us to see. Then, after that, there is another role to be played by the dust particles, and that is in the basic formation of the clouds itself. So, when you observe, whenever you have observed any kind of a cloud out in the atmosphere, that is what? That is a condensed form of water vapor. Water vapor has condensed into ice or maybe super cool liquid water droplet. But can condensation happen in absolute thin air? Never. Condensation always requires a surface. Whenever condensation has to happen, it will always require a surface, be it the bottle or the surface of the water bottle that you have taken out from the fridge, or any utensil you have kept out of a refrigerator. Condensation, or the grasses on the ground, condensation will never happen without a surface. Now, these dust particles, they provide that surface for condensation to happen. Okay. Now you have various different types of particles. Few of the certain chemical particles, they don't allow water to stick onto them, or they don't allow water vapor to even come close to them. Those are what are referred to as hydrophobic nuclei, right? But dust particles in general, they allow water to stick onto them, and they allow the condensation to happen. They are what are referred to as hygroscopic nuclei. So they form, allow, or rather provide a surface for condensation to happen, and hence form, help in formation of clouds, right? And these are what are also referred to as hygroscopic nuclei. Nuclei allow water to accumulate on the surface or stick to the surface. So that is the major role played by the various components of the atmosphere. So when we talk about the various components, you have the gases and water vapor which will carry out the greenhouse effect. Both of them, the various different gases as well as water vapor, they will allow for the greenhouse effect. The gases will provide air to breathe in as well. Water vapor will provide that amount of rainfall, various atmospheric disturbances as well. And dust particles, they allow you to see during the darkest of the night. And the dust particles, they also help in the formation of the clouds, because they will attract the water vapor, or they will allow that platform for the condensation to happen. Okay. Now, that is where we have the role of the various different components of the atmosphere. Now, when we talk about the various gases, their proportion overall, if you will observe, nitrogen is the most predominant one with around 78% of the atmosphere consisting of only nitrogen molecules. Then it is followed by oxygen, then argon, carbon dioxide, and so on. Ideally, many of the candidates, they get confused that after nitrogen and oxygen, they feel it is carbon dioxide, which is the third most dominant gas. But that is not the case. So if you are getting confused in this, you should be aware of the top four. The top four is something you should be aware of. Okay. You don't need to remember the exact data here. Okay. But you need to know the order or in the form of the presence of gases. Okay. Now, after this, we come to the portion of the different modes of heating. How is it that heating is carried out? So basically, no, please don't mug up the percentage. Yes, they are also called as condensation nuclei. That is correct. Is it not the moonlight that we are witnessing during night times? Rather, it is diffused light of the solar rays. So that is when the moon is there, my dear friend. What in those scenarios when the moon is not there? Are you able to see something in the cases when the moon is not there, or are you completely blinded by it? You'll be able to see something. Where does that light come from? Now, don't tell me that because I have a torch or a flashlight, that is why I'm able to see. Even without an artificial light, you will be able to see. And that is because of the scattered light. Okay, right? Now, yes, all the greenhouse gases, be it carbon dioxide, dioxide, sulfur hexafluoride, nitrous oxide, methane, then you have chlorofluorocarbons in certain cases, hydrofluorocarbons, water vapor, all of them. They behave in a similar manner in terms of the greenhouse potential that they have. But the warming potential is different for different gases. Okay. So now we come to the portion of how is it that heating is done? How is it that the heat is received? So primarily, when let's suppose if I ask you a basic experiment, if you conduct a basic experiment, let's suppose you have a large halogen bulb, the older torches that you would find with your grandparents or your great grandparents, the ones made out of aluminium where or steel, where if you throw it to somebody, that person is gone forever and that person's head is easily blasted. That older big torches that you have. So if you have any of those big torches or any halogen light in general, you shine it on a surface. Now, which is it that will get heated first? Will the air here will A get heated first, or will that surface B will get heated first? What is our understanding in this? So for majority of us, the understanding is incorrect. So it is B which will get heated first. Right. Why? Understand this basic logic. Why is it that B will get heated first rather than? So if ever, or I'll take another analogy, and I think you would have observed this. If not, try to observe it now. If ever you have sat in front of a room heater, or do one thing, any heater or stove that you have, keep your palms above a particular height. Now the air in between will get hotter. It is not very hot, but your palm, it will start burning after some time. Why? Because this is a solid surface. Here the molecules cannot move. So the heat which is gained in this molecule, that energy the molecule will retain. And the excess or the continuous heat which is being provided will continue to raise the temperature there. But when we talk about A here, A is made up of gases. Those gases are free to move. So that is why when we talk about these gases, they will be free to move. The molecules will be free to move. So the effective rise of temperature in A will be very less as compared to a solid surface. That is why even when we have the solar rays heating the surface, it is the atmosphere directly receives some amount of heat, but not so much as much we compare it to the surface of the planet Earth. It is a surface which gets heated quite incredibly. And then the heating of the atmosphere happens. How does that happen? That is something we'll cover tomorrow. Okay. So that is where we'll restrict the session here for today. We'll take up a few questions. The PYQs here of geomorphology, we'll discuss it tomorrow. As of now, I want you to take a look at those PYQs, think about it, what could be the answer written for those mains PYQs, and then we will discuss it tomorrow in the first part of it, first part of the class itself. Okay? Map pointing, correct. So let's have certain areas for map pointing. So I want you to find out where is it that Nagorno-Karabakh is situated. For this, if required, take a look at Google. Then look at Caspian Sea and countries surrounding it. And while you are doing it, locate River Volga. Then Black Sea. Then Sea of Azov. Then Sea of Marmara. Then Malacca Strait. Then Strait of Hormuz. Then look at Bab al Mandeb. Where is it? Then after that, in this area itself, I'll give you a hint. Locate Gulf of Karabogas. Then look at Rhine River, Rhine, and the entire Rhine Valley as well. Entire Rhine Valley. Mineral rich, which has formed the backbone for industrialization of Germany in the earlier days. Mineral rich. Okay. Then after that, look at Dardanelles Strait, then Strait of Gibraltar, then after that Bosphorus Strait. Locate these areas. Okay, just look at the map, take the help of the Google if required. Okay, now Tehseen, that is totally your call, depending upon how is it that you want to shape your future. That is something which you should take a call. If it helps your understanding in civil services, fair enough, that will be beneficial. But don't let only the civil services dictate the subjects that you are choosing for your study in general. What causes heat waves not to move out of Earth's atmosphere? It is the low level of energy of the terrestrial radiation. Only B will be hotter, but first air will be heated, not significantly, my dear friend. Air will be receiving some amount of heat, but after a point of time, it is the air in contact with B which will be the main source of heat. Okay, we will develop that concept when we talk about the portion of atmospheric heating. You will understand that. Abhishek, you said that P waves travel at much faster speed, and you said that the speed is directly proportional to the density. As we know, the density of liquid and gas is less. Not always. Not always. P waves can only travel through liquid and gaseous. P waves can only travel through liquid and gaseous. No, P waves can travel through solids as well. P waves can travel through solid, liquid, and gases, all of them. Right? Yes, Rashida. If you have an understanding of that, it will be a good portion for optional. Leaderboard you want to see. Okay, we'll take a look into that in a brief moment. And why water gets evaporated to form stalactites and stalagmites? Because of temperature in general. Water can evaporate at room temperature as well, isn't it? So not all that water will evaporate, some of them. Questions, PYQs, Lakshmi will discuss tomorrow. As of today, I want you to take a look at those questions. Try to understand if you can solve them or not, and then we'll take a look at it tomorrow. We'll discuss it tomorrow. Uh, Greenhouse effect is important portion of GS. Wavelength, short wave and long wave radiation, UPSC tends to ask. Okay. Garvit, revise as many times as you can and take as much practice test as you can. Why it is referred to as a greenhouse? Because it would allow the growth of the plants in that region. For geography as an optional, yes, you need to be covering more than this present lecture series, because in this present lecture series, we will be discussing only around 55 to 60% of the optional, not more than that. But there are many areas that you need to cover otherwise. And starting point of the atmosphere is the surface. End point of the atmosphere is not depicted. It is basically, it slowly and steadily vanishes into thin space. Yes, Tehseen, that is a good one as an optional. Uni, it takes a lot of time to make notes. That is because at this point of time, when you are reading it for the first time, it might happen that you are not very sure which is important point or not. So always advisable to make notes while you carry out your revision purposes. Okay. Tambolo, Aniket, is basically any kind of a small island when it is connected to the mainland by the deposits. So that deposition which connects that mainland to the island, that is Tombolo. Okay. So ozone layer, Praveen, we will study it in the portion of environment and ecology. If I take the session, or in general environment and ecology, you study the ozone layer, you study about the Montreal Protocol, the Kigali Amendment, all of that. After striking, what thing light gets reflected, or does it get only retained in? So light basically after striking the dust particles, that is where it is scattered. At in morning as well as evening. Vishal, unless and until revision is carried out, my dear friend, it is not going to be